Hey guys, we introduced what we call one-step equations, equations that involve one step. Now we're going to go a little bit further and explore some more types of equations where we are involved now in doing something a little bit more than just the one step. Let's watch and look carefully. In these examples, you're going to notice that they look simple, they look easy. However, the first one is our normal one-step equation. Here, they are a little bit different. Let's see and do the first one as we normally do it, just to revise, and then we'll do and continue on with the others. That way you can see the difference between all of them. A take away 4 equals to 9. We learned that we have to use what we call the law of opposites. We need to find A minus 4, we add 4, and we add 4 on this side. What we do to this side, we have to do to that side. Minus 4 plus 4 is gone, you're left with A. 9 plus 4, our answer is 13. That's the basic one-step equation. Looking here though, it looks similar. However, what do we notice? We notice that the pronumeral coming second. It's not at the start of the equation. That can sometimes complicate it for us. So, let's do it and see how it actually gets solved. What I like to do, and what I advise you to do, is something very simple. It's a little trick. We put our equal, put our 12, and we want to change this to make it look like that. So what do? We swap those over. This is a positive 6, and this is a negative x. So negative x comes first, positive 6 comes second. Now it looks similar to that one there. Do this little step, it makes life easier later on. Now, well, simple. Plus 6 becomes minus 6. What we do to one side, we do to the other side. 12 take away 6 is 6, and of course plus 6 minus 6 is gone. We're left with negative x. Now we know in equations we want to find x by itself, not negative x. So another trick is to basically take this negative and throw it over the other side, which becomes x is negative 6. X equals to minus 6. How do we know it's correct? Well, let's try. X equals to minus 6. 6 take away minus 6, because x is minus 6. So 6 take away minus 6. We know two negatives next to each other become a plus. 6 plus 6 is 12. That's how easy it is. Let's go through it one more time. So we notice this is a equation similar to the one on top. However, we notice that the pronumerals on the end make it easier. Swap them around. Negative x, there it is. Positive 6, there it is. Very important to remember, negative x. It's not just x, it's negative x. Put it at the front. Positive 6, there it is. There's our new equation, negative x plus 6. Now we solve it normally. Plus 6 becomes, we want to take it away. So take away 6, the law of opposites. The opposite of plus is minus. 12 take away 6 is 6. Plus 6 minus 6 is gone. We're left with negative x. And we want to know x. We don't want to know negative x. Another trick, minus, you just throw it over, becomes minus 6. X equals to minus 6. We're going to follow the same procedure here. Let's go through it and see if you can go through with me. 5 take away y equals 7. Well, we notice that the pronumerals at the end, or here, we would like to put it at the start. What do? We swap them over. This is a negative y. This is a plus 5 equals 7. Now, it looks similar to these. Now, negative y plus 5. Well, we know that we can now take away 5 using the law of opposites. Negative y, 7 take away 5 is 2. This is negative y equals 2. Remember, we want only y, so we just say u, go over there, and becomes minus 2. So all of a sudden, we've taken the minus and just thrown it over. Y equals to -2. It is that easy, guys. We'll do another one. Now you should be getting the hang of it. What do? -12 minus b equals 6. We notice the b would like to put at the front. It's easier to work with. Reverse them. So minus b minus 12 equals 6. We've reversed it. Minus b is at the front. Minus 12 there. We just swap them over. Now let's do it. Minus 12 becomes plus 12 on one side plus 12 on the other side. We're left with minus b. 6 plus 12 is 18. Minus b equals 18. We only want b. So we said the minus, just throw it over. It's that simple, guys. Very easy. We follow the steps. One trick at the start, one trick at the end, and you solve it very easily. No confusion and no error, no mistakes. This is one way of doing these. And now we're going to look at some more equations where we're involved with division. Let's do that now, and hopefully after this you'll become very good at these. Okay guys, we're going to do some examples with division now. Let's go through them. The first one is similar to the one-step equations. X divided by 7 equals to 8. We know fraction bar means divided by, so x divided by 7 equals to 8. We would like to know and find the value of x. So we know the law of opposites says that divide, the opposite of it is times. So we times 7 and we times 7. That means x here, 8 times 7, 56. X equals to 56. It is simple. Now here, what do you notice? Look carefully at this question. What do you notice is different between this one and that one? Have you found out? Well, I can see that in the top example, our denominator, our numerator is x and our denominator is 7. While in this example, our numerator is 15, our denominator is b. So here, the numerator is missing, and here the denominator is missing. So there's a slight difference here, and it will make a big difference if we don't do it properly. So what are we going to do? Whenever the denominator is down the bottom, very simple, we have this little trick. We swap these over. We swap these over, so we have 15 over 3 equals b. So look carefully. I've swapped the b and I've placed the 3 instead, and I've put the b where the 3 was. So here you can tell I've reversed it. You only do this when the denominator is missing. So now 15 divided by 3, b is 5. So another trick for you, very easy. You need to just distinguish and identify, okay, I notice here the denominator is missing, while here our numerator is missing. So when the numerator is missing, you just do normal, follow the simple rules of multiplying. And here when the denominator is missing, just reverse and swap them over, and you're going to get the answer straight away. So here, once again, you look closely and you realize, hang on, the y is on the denominator. We have to use our little reverse and swap trick. So swap them around. 24 over 3 equals y. Swap them over. That means y is going to be 24 divided by 3. Y is going to be 8. Now do this one yourself, very quick. X is on the denominator. We have to use our swap and reverse trick. 36 over 9 equals x. We've swapped them over because the denominator is down the bottom. That's what's missing. X, 36 divided by 9, x is 4. Does it work? 36 divided by 4 is 9. 24 divided by 8 is 3. And 15 divided by 3 is 5. Let's try it. Put the 5 back in. 15 divided by 5 is 3. It works as well. So here you can tell that again we swap and reverse and we can work it out. Very important to identify that we do this when the denominator is missing. The denominator is missing here. The denominator is missing here. So it's very important for you to straight away identify that. You'll get them correct once you follow these little steps and these little tricks here and there.